All right, let's take a look at our lesson for today. Today we're going to be looking at the derivatives of cosine, sine, e to the x, and ln x. This is the way that College Board has it structured. I typically would do all the derivatives of all the trig functions all at the same time, but they're breaking them up. We do two in this lesson, and then in the next lesson, we do the rest of them. Well, no, two lessons down, we do the rest of them, all the other trig functions. So we're just going to focus on sine and cosine today as far as trig goes. So let's take a look at them. So there's some patterns that I would like for you to notice, and yay, I know you're going to be pretty excited. These are additional, questions for formula quizzes. Yay! All right, so here we go. Y'all are like, stop talking about those. All right, so if the trig function starts with a c, so if the trig function starts with a c, the derivative will be negative. This applies to all of the trig functions that start with the c. So when I memorize things, I need patterns to memorize things, and this is one of the patterns that I have in my brain. If the trig function starts with a c, its derivative is negative. If it doesn't start with a c, then its derivative is positive. These two I also paired together in my brain because they are basically derivatives of each other. The derivative of cosine is negative sine, and the derivative of sine is cosine. So very, very close. The only unusual thing is cosine starts with a c, so its derivative is negative. Okay, so those are two formulas to add to our list. Then we have derivatives of the exponentials. And I don't know if you remember in pre-cal, like e to the x scared people, like, oh my gosh, e to the x. But in calculus, we love e to the x because the derivative of e to the x is e to the x. It can't be simpler than that. This one right here, and I'll just go ahead and circle the little thing. I don't know why, but this poor little thing gets a bad rap. Lots of students forget it. They just forget it. I don't really know why. And I say this every single year, and I really try to warn students that this one is one that people forget. So, I just want to throw that out there. So that's important not to forget it. It's almost exact, well, it is the exact same thing as this. The derivative of a to the x is a to the x. This is the part ln a. Over here, it would be e to the x ln e. And do we remember what ln e is? Natural log of e. What is the value of the natural log of e? Well, e is like 2.7 something something, but the natural log of e is 1. It's 1. And that's why we don't write that here, because that's 1. These are virtually the exact same formulas. These are the same formulas. It's just that we don't have to write ln e because it's 1. Okay, so we just don't write it. Okay, we doing okay? Then we have the derivatives of logarithms. The derivative of natural log, again, is easy because it's 1 over x. I mean, really, it's 1 over x ln e, and we know ln e is 1, so we don't write that down there. The derivative of log base a, this is the base, is 1 over x ln a. So I hope you notice the similarities between the exponential and the logarithmic derivatives, and that is they involve natural log. Both of them do. Either you multiply by natural log in the numerator like this one, or you multiply by natural log in the denominator like this one, but they both involve natural log. Okay. Questions on those formulas? So those are 6 new formulas for us. So let's practice using them. Let's go. We've got a few examples. Okay, this one has an exponential in it, 7 to the x. But what I want you to start thinking about is our, we'll do the alternative form, our definitions of the derivative. This is how we're going to see definitions of the derivative in really weird ways like this one and, these two. So I'm just going to write down the limit as x goes to 0. I'm thinking about this of f of x minus f of 0 over x minus 0. Okay, so these two things are the same. This is how you would normally see it. That's how we are accustomed to remembering it, but it's the exact same thing. So I'm going to pause here for a second. So, and we've practiced with problems like this before where we have to recognize the limit as the definition of the derivative. So what does that mean? What that means is I need to write out here, what is this going to give me? This is going to give me f prime of 0. That's what that limit is going to give me, f prime of 0. How do I know? That's because that's what this limit would give me. This limit would give me f prime of 0. Okay, because this is my 0, there's my 0, and there's my f of 0. That signifies, in the alternative form of the definition of the derivative, that tells us what we're getting when we do that limit. Okay, are we okay? All right, so now that we know, and it's really important, I'm just going to write, this is important to write. In other words, you need to write this part, what this equals. You need to identify that this is going to be the same as f prime of 0. It equals it. You need to write equals f prime of 0. Okay? That's what it equals. And so what are we going to do? We're going to pull out what f is. So f is this location right here. Okay? I just highlighted those. That's where f is. So f is 7 to the x. That's what it is. I read it out of the formula. You should be able to read it out of the formula. So what does the formula want us to do? Well, if we were to do that limit, which is not an easy limit to do, let me just say, that's not an easy limit to do. If we were to do that limit, what is our result? Our result is f prime of 0. So we're going to do a shortcut way by recognizing what this is, definition of the derivative, and we're going to do a shortcut. We're going to pull out the f, we're going to take the derivative of it. And that's one of the new formulas that we just had up above. The derivative of a to the x, ln a. So the derivative of 7 to the x is 7 to the x, ln 7. Now, what are we supposed to do with the derivative once we have it in this particular case? We're supposed to plug a 0 in. We're supposed to plug a 0 in for x, because that's what we're looking for. That's what we've got right here. We're supposed to be f prime of 0. So f prime of 0 is 7 to the 0, ln 7. And we know with all of our math abilities, we know what a number to the 0 is, right? It's 1. So f prime of 0 is going to be ln 7. 1 times ln 7, which is ln 7. And that's our answer. Okay, how are we doing? I really don't know why I called that example number 2. It's actually example number 1. Who knows? I don't know.
So how do you know that you only have to use 7 to the x?
Good question. So the way that I know that is by the formula. That's how I know. I know that this this piece right here, whatever's in this spot in the formula is f of x. That's a location. So I look at my formula and I see whatever's in that spot, that is what f of x is. So that's how I identify what f of x is, by the location in the formula. Okay? Other questions on this problem?
But like, if it's like the f of x and f of 0, why would it be 1 in the case of 0?
Okay, let me get, sorry, it's doing that silly thing that drives me bananas. Okay, here we go. I'll go right back. Okay, now what was that, dear?
Like, since it's 7 to the x minus 1, why is it f of 0 not f of 1?
Why is it f of 0?
Or
and
does
f of-
it-
Okay, so let me write out the other, let's just write out the formal alternative form. So the limit as x goes to c, I don't remember if we use a, b, or c in our formulas, it doesn't matter, c of f of x minus f of c over x minus c. Okay, this is my what this equals f prime of c. That's what it equals. This is a formula that we memorized, right? This is the alternative form of the definition of the derivative. So I'm looking at that formula and I'm trying to make sense of how that formula relates to the problem that I'm doing, number 2. How does it relate to it? Because I personally don't really want to do the limit of 7 to the x minus 1 over x. I really don't. That's going to be really hard. So if there's a way to shorten my work and do it an easier way, I'm going to do that. So I look at it and I see that they basically have replaced, okay, so they replaced the c is 0. Now, let me show you, because 7, okay, this right here would be 7 to the 0, right? Because it's f of c. So I take my f, which is 7 to the x, and I plug in a 0. And what is 7 to the 0? It's 1. That's why there's a 1 right here, because that's 7 to the 0 using this formula, x minus 0. So it's all because of the formula. That's the reason I'm able to do anything, is that I am matching it to the formula and I am doing a shortcut. I'm actually going to take the derivative. I'm going to sub in the c. Does that help? Okay. Any other questions? This is highly abstract, and I completely understand why this is confusing. It's highly abstract. Okay? We have one more like this, which is number 3. Okay, we're looking at this. In this case, they are making it, I don't know if it's easier or hard. They're actually putting the f of x here, so we, are focusing on this formula right here. This is the formula that they're using. Okay, that's the one that we're using. And instead of putting the cosine in there, they say f of x is cosine. Well, okay. I mean, that's fine. I guess, to be honest, in this form, it's easier to recognize that this is definitely the alternative form of the definition of the derivative, because it pretty much matches this one 100%, right? It matches it. So what would this give us? We need to write it down. Absolutely. This is going to give us f prime of pi over 2. That is the result of using this formula. That's what we would get. Because, how do I know? Because that's what this says. That's how I know, because that's what the formula says. I'm just using a formula. I'm not making anything up. I'm just using a formula. So if that limit gives me f prime of pi over 2, I don't really want to work that limit, to be honest with you. I want to do a shortcut. I want to just pull out the function. All right, so I'm just going to pull out the function. We know f of x is cosine of x. Okay, I want to do that. And then I want to do what this says. I want to take the derivative and sub in a pi over 2. That's what I want to do. Why? Because that's easier. So we take the derivative, f prime of x. The derivative of cosine is a negative sign. Then I sub in f prime of pi over 2. So that's negative sine of pi over 2. This is a unit circle value, which we are all really good at unit circle values, hopefully by now. Right, sine of pi over 2 is 1, so negative 1 times 1 is negative 1. So f prime of pi over 2 equals negative 1. That's my answer. So let me also explain the importance of writing this down. This part right here, this equals this business. Why is that important? That's important because I'm writing this down. Okay? What I'm saying is, without having to go back up there and rewrite the limit all over again, which I would have to do if I'm not doing this, I'm saying that this is equivalent to this. That limit is going to give me f prime of pi over 2, and f prime of pi over 2 is negative 1. Therefore, that limit answers negative 1. You with me? It's kind of like the transitive property. Y'all remember that from a long time ago? If this equals this and that equals that, then the other, that kind of thing. That's what we're doing here. That's why it's important. I'm just going to write this again. This is, if you don't write it, you're going to lose a point. This, unless you want to rewrite the limit all over again and say the answer is 1. You can do that. This is important to write. Okay, important to write. And I'll just write down what the alternative. Alternatively, you can copy the limit and say it equals negative 1. That's the other thing you could do. If you don't want to do equals f prime of pi over 2, if you don't want to do that, that's okay. You can recopy the whole limit and say it equals negative 1. That's the other option that you have. I personally, it's faster to do this. I would prefer to do that, but you don't have to. You can do either one to get the point. All right, questions on that? So are we getting a little more comfortable with you seeing, like recognizing the definition of the derivative in a problem, I'm hoping? Okay.
So basically we just have to write that because it's part of the setup.
Yes, exactly. Because it's part of the setup. It's really what we're doing. By writing this, we are telling whoever's reading our work that we're going to branch off. We're going to pull out the function, take the derivative, and stick a pi over 2 in it. That's what we're telling someone in our work. Okay? All right, number 4. So we're given a function, f of x. They want us to find f prime of 0. Okay, we can do that. First thing we need to do is find f prime of x. Here we're going to use a combination. Well, actually here, the functions are the ones we just learned the derivatives of. So let me remind you, a couple of days ago we learned this derivative rule. The derivative of a constant times a function. We can pull the derivative, the constant on the outside, and do the derivative of the function. Remember that? It's called the constant multiple rule. Okay, that's a rule. We're allowed to do that. That's what I'm going to be doing here and here. I'm going to do that rule twice. I'm not going to mess with the 3 and the negative 11. I'm not doing it. I'm just going to pull it aside, ignore it, and then apply it. Okay? So, the derivative of sine is cosine. So, the derivative of sine is cosine, and I'm just pulling down the 3. It's just a multiplier. It's just hanging around. Again, I'm using this concept right here that I just wrote down. I ignored the c, I took the derivative of the function, and then I just multiplied the function by that number. Okay? I'm going to do the same thing here. I'm going to ignore the negative 11. I'm going to ignore it. The derivative of e to the x is nicely e to the x, and that's my derivative. Okay? So what they're asking us to do is find f prime of 0. So f prime of 0 equals 3 cosine of 0 minus 11 e to the 0. Okay, we can do that. f prime of 0 is going to be, let's see, cosine of 0, that's the unit circle value, 1. So 3 times 1 is 3. And then we know e to the 0 is 1, right? E to the 0 is 1. So f prime of 0 is 3 minus 11. What is that, negative 8? My arithmetic is horrible. Is that right? Negative 8? Okay, perfect. Are we okay? All right. I'll pause here for a moment, make sure y'all are all caught up with me. All right. Okay, I think we have a few more examples. Let me check. Yep, we have 2 more. Okay. So here we go. We're going to find the equation of the tangent line. You know, we have done this before. We'll keep doing it. We're going to do this over and over again. So we use my favorite equation of the line, y minus y1 equals m times x minus x1. On a formula quiz, you can certainly use that to show equation of the tangent line. There is another formula that's in the formula quiz, y minus f of a equals f prime of a times x minus a, and we might have used a different letter than a. I can't remember, either a, b, or c. Either one of those formulas is perfectly fine to give me. They both mean the same thing. This one is more formal. It's more specific to exactly what we're doing, but this one I am fine with too. Since it's my favorite, we can use that one too. All right, so what do we know? So we need the y value of this point. This is the x value. We need the y value. So I need to find f of 1 is what I need to do. I need to find f of 1. That's ln of 1 plus 2 to the 1. Now, there are some natural log values that you just have to memorize. I mean, there's no way around it. We need to know what ln e is. We already talked about that today, right? ln e is 1. We also need to know what ln 1 is. Do we remember what ln 1 is? ln 1 is 0. We have to know that. Put it on your memory work. That's like non-negotiable because it's going to be in problems. It's going to pop up in problems. So I'll just write them here. So we need to know that ln of e is 1, and we need to know that ln of 1 is 0. These are just values that we have to have in our brain. Just like 1 plus 1 is 2. I mean, just that basic. We need to know that. So f of 1 is what, 0 plus 2, which is just 2. Okay. So, great. I've got y minus 2 equals something. I'll come back to that. X minus 1. Does everybody understand where I got the 1 and the 2 from? 1 is my x value, and 2 is my y value of my point of tangency. All right, so now my job is to find what goes here. What goes there? How do we find slopes of tangent lines? Exactly. The derivative. The first derivative gives us slopes of tangent lines. It's like a slope machine. We can put any number in it and out will pop the slope. All right, so we need to find f prime of x. So f prime, so I'm going to just write a note here so that we remember in case something we forget. So we find the first derivative, then substitute x value in. Okay, that's what we're doing. And that's going to give us our slope. Okay, so f prime of x. So the derivative of ln x is 1 over x. That's something you will memorize. That's just, it's a memory. It's a memory thing. The derivative of ln of x was 1 over x. Plus The derivative of 2 to the x is 2 to the x ln 2. That's my derivative. Okay?
Can you repeat what you just said?
Yes. So the derivative of ln x is 1 over x plus the derivative of 2 to the x is 2 to the x ln 2, and that is my first derivative. That is my first derivative equation. Okay, I've done this right here. I've found the first derivative equation. My next step is to substitute the x value in, and the x value in this case is a 1. So I'm going to substitute the x value in, so f prime of 1 equals 1 over 1 plus 2 to the first ln 2. Okay, so f prime of 1 is 1 plus 2 to the first is 2, 2 ln 2. And I know that's not pretty. Okay, I probably just upset it. Oh, I'm so sorry to call you not pretty. You're lovely, but a little prickly. I mean, 1 plus 2 ln 2 is kind of weird. I'm not going to lie. Now, if we were working multiple choice question, they would probably use a log rule here. I don't need to use a log rule. I'm just telling you that they probably would use a log rule here. Do we remember a log rule that would apply in this circumstance? Yes, we take this 2 in front and pull it up as an exponent. So this is the same thing as ln of 2 to the second or ln of 4. Again, you don't have to do that for me. You can leave it as 2 ln 2. I'm just telling you that if this is a multiple choice question, they would make it ln 4. Okay? That's what they would do. So now we're ready to finish our tangent line equation. So I'm going to write it out here. Just write it in a different color. So I've got y minus 2 equals, and I'm going to put the derivative, the slope value in parentheses because it's just a weird number, right? And I'm going to put it back like they would write it on a multiple choice question. 1 plus ln 4. Okay, that's my slope times x minus 1. And this is my tangent line. The other way to have written it is y minus 2 equals 1 plus 2 ln 2 times x minus 1. Either of those is perfectly fine with me.
Do you still leave the constant in the left or leave it over?
This one right here.
So the minus 2.
Oh, no, you can move it over. That's perfectly fine. You can do y equals if you want. Perfectly fine. Y equals 2 plus all that mess. Yeah. All right, is everybody okay? Okay. One last question, and this one actually is just a formula right here. It's pretty straightforward. So they just want us to find the derivative. So f prime of x. So this is log base 3 of x. So we would look at our, you probably haven't had time to memorize it, but you could look at your rule. And the rule tells us that it's 1 over x and then ln of the base, which is 3. And I mean, that's it. It's just a formula. And this base has to match, those match. Okay, these two things match. That base has to match the natural log. I would tell you one of the most common mistakes I see with this derivative is students getting the 3 and the x mixed up. Please, please, please pay attention and don't mix the 3 and the x up. Okay, the x is by itself. The 3 is part of the logarithm. Okay, I'll just write this, don't mix these up. Because like I said, that's the most common error I see in this derivative. Don't mix these up. Okay, don't mix the x and the 3 up. Okay?